All right, so last section we're going to look at this week is 1.6. And it's on functions and how we can take two functions we have, combine them in a way, and create a new one. Right? And the big thing we're going to look at is domain and range. Because we can't, for example, you can't divide by 0. So that's one thing we got to be really careful about. And we don't want to take the square root of what kind of numbers? Yep. Negatives. Yep. So those are the two big things we're going to have to look for. So when you start creating new functions, you're going to have to tell me what the domain is and what the range is of those functions. And the first way we're going to take two functions and create new ones is literally just add, subtract, multiply, and divide them. Right, so kind of as a simple example, if you had f of x equals 3x, g of x equals 5x, and I said create a new function by adding them together. Well, f of x plus g of x would equal what in this case? Yeah.
8x.
Yeah, 8x. So there's a new function. I don't know what we want to call it. We just call y equals 8x. So there's a new function, and it was created from combining the two functions that we already had. In this particular case, domain and range, it stays the same. You can take any number you want and multiply by 3. You can take any number you want and multiply by 5. So the domain is all real numbers. And when you combine the two functions together, the domain is still all real numbers, because you can take any number you want and multiply by 8. Okay, but when you start dividing, then that can get a little tricky if you end up with a variable in the bottom. Let's look at another one. Okay, here's two other functions. These aren't like terms, though. Like f of x and g of x I had up on the right, those are like terms, so you can combine them. This is an x squared, this is a square root. So if you want to create a new function by, let's say, adding them, bless you. Literally all you can do is put a plus sign between them. There is no way to simplify that any further. Okay, let's look at this one. Let's create a new function by dividing them. So Nick, what would go in the top if I'm creating a new function? F of x over g of x.
X squared.
X squared would go in the top. Holly, what would go in the bottom?
Square root of x plus 1.
Yep, square root of x plus 1. And now, so that's good. It's a good first step. But what did we do there that we shouldn't leave in a final answer? Yeah. Right, we shouldn't leave that square root in the bottom. So now this part is just what we call rationalizing the denominator, and it's probably something you would have done in like algebra 1 or 2. We just don't leave the square root in the bottom. Okay, so we fix that by multiplying top and bottom by the square root. When you do it in the top, again, these aren't like terms, so there's nothing you can do to combine them, so we just leave it. X squared times the square root of x plus 1. But what do you get in the bottom when you multiply the square root of x plus 1 times the square root of x plus 1? Yeah, quote.
X plus 1.
Right. It's like raising the square root of x plus 1 to the second power. You just have x plus 1. All right. So in that case, when we created a new function by combining two that we had together, there was a little bit of simplifying we had to do because you're not supposed to leave the square root in the bottom. Any question on how we simplified that? Okay. And in the book, they give more examples. I think they do an add, subtract, multiply, and a divide. All right, so what is the domain? Well, in order to figure out the domain, when you take and create a new function, you can kind of think of it like a Venn diagram. Let's say this is all the values that are in the domain of g of x. Right? And then let's say we had this is all the values in the domain of f of x. If you combine g of x and f of x together in some way, the domain becomes the overlap. Bless you. It becomes the numbers that are in the domain of g of x and in the domain of f of x. So you're basically looking for something like that. It has to be numbers that are in both domains. Now, the only extra thing that can happen is if we create two functions and we use division to do it. Not only does the domain have to be all the numbers that were in the first function, all the numbers that were in the second function, but we also have to make sure that we don't divide by what number? Yep.
0.
Right. We also have to make sure that we don't end up with a 0 in the denominator. So if you had something like, let's say g of x is x cubed, f of x is 2x. By themselves, the domain of each of those is all real numbers. There's no square roots, and there's no fractions in either one of those with variables in the bottom. But if you combine them like this and create a new function, you get 2x over x cubed, which reduces to 2 over x. So the original function, you could plug in anything you wanted here. This function, you could plug in anything you wanted here. But you cannot plug in anything you want here. What number would you not be allowed to use for x in that one? Yep.
0.
You would not be able to use 0 in the domain. Yep. Yeah.
Wouldn't it be x squared on the bottom?
X
cubed?
Yeah, thank you. Yeah, that'd be an x squared. Yeah. Still the same answer. You would not be allowed to plug in 0 for the domain. Yep. So we just got to be careful when we do division. All right, so let's try this one. So we have two square root functions. And the idea here is before you combine them, figure out the domain of each one of them. And then when we combine them, it'll be a little easier. That should pass. So now, let's start with the square root of x plus 3. We want to always make sure that we're taking the square root of a number 0 or higher. So what does that mean x would have to be in this problem to ensure that that square root always comes out 0 or higher? Yep.
X is greater than or equal to -3.
Greater than or equal to -3. So -3 is the lowest value you could pick, and you can include it. So we use a bracket. Infinity is the highest value you can pick. You can never reach infinity, so we put a parenthesis. Okay, how about the bottom one? If you want to make sure that x minus 2 always comes out greater than or equal to 0, what would be the numbers you could pick to plug in for x there? Like you couldn't plug in 0. 0 is too small. You get a negative number. Yep. 2 or greater. Yep. So you can pick any number that's 2 or greater. All right. So now we have the domain of each one of them individually. Now let's combine them together. And remember that when we combine them, the domain is the overlap of those two. Okay. So when we combine them, these aren't like terms. Okay? For square roots to be like terms, you have to have like square root of x plus square root of x. Then you could say that that's 2 square roots of x. But we don't have that here. We have an x plus 3 under the for the first radicand. We have an x minus 2 for the second radicand. They're not like terms. So when we write this down, we literally can just write that, and then that's the final answer. So how would I write f of x plus g of x? Yeah, cool.
Is it square root of x plus 3 plus square root of x minus 2?
Yep, they're not like terms, so that's all you can do. Now I want the domain of that. So the domain is the overlap. It's all the numbers that work here and here. So what would be the overlap between those 2 domains? Everything, yep.
The overlap be
Yep.
2 infinity.
2 to infinity, yep. So if you think of it like on a number line, here's -3, here's 0, here's 2. The first domain is from -3 going up forever. The second domain is 2 going up forever. The overlap is 2 going up forever. Any questions on finding the domain there? All right, let's try this one. Again, they're not like terms, so we're pretty much just going to write that. There's nothing we can reduce here. So Moises, what was f of x?
Square root of x plus 3.
Yep, and g of x?
Square root of x minus 2.
Square root of x minus 2. Okay, now I want to know my domain. What would the domain be here? Yeah. Say it again. No, not 3 to infinity. No, you got to think real numbers. So you got to think like decimals and fractions too. Thanks. Anything what? Yes, greater than 2. Why isn't it the same domain as the last one? Yeah. Right. Right. So not only do you have to include the overlap between the 2, but you also have to check if you use that overlap, is there any number that would cause you to divide by 0? And yes, this time there is. So it's 2 to infinity, not including 2. Any question on that one? Let's try this one. We should be able to get the domain here without graphing it. Are there any square roots in this problem? No. So we don't have to worry about square roots and negatives. That doesn't come up here. Are there any fractions with letters in the bottom? If there are, then we need to worry about dividing by 0. So what do you think you are not allowed to use for x here? Yeah? You can't use 0. Can you use anything lower than 0? Okay, could you use anything higher than 0? So it's just 0. So you have to describe that in 2 pieces. Okay. Anything lower than 0? Well, what's the lowest thing you can think of if you're thinking of things lower than 0? What's the lowest? Yeah? Negative infinity. And what's the highest? You can go right up to, but not including what number? Yeah?
0.
Yeah, go right up to, but do not include 0. Or, now we can go 0 or higher. What's the lowest number you can think of if you can pick something that's going from 0 up, but not including 0. You can go right up to what number? Yep.
Up to infinity without reaching it.
So what's the lowest you can go?
Oh, lowest is 0.
The lowest is 0, but not reaching it. So you can go 0.00000000001. That's okay. But you can't do 0. Okay, so that's your domain. Now, the range. Well, think about what would happen if you plugged in 4 for x and simplified this. What would you get if you plugged in 4 for x? Yeah? You get 1. What if you plugged in 6 for x? 1. What if you plugged in 13 for x?
You get 1.
You get 1, right? Well, don't plug in 0. Can't do that. But what if you plugged in -2 for x? What would you get?
And you get -2.
Yeah, what would you get?
-2.
No, if you plug in -2 there, you'd have 2 divided by -2.
Or -1.
-1. What if you plugged in -5?
Also -1.
You'd also get -1. So if you graph this, you're only going to see 2 numbers in the range. So go to the absolute value of x divided by x. If you plug in a value less than 0, you're always going to get -1. If you plug in a value more than 0, you're always going to get +1. And that's it. So the range is literally 2 numbers. So for that, we don't write it as an interval. Okay? We write things as an interval when you have to describe like every single number between a low and a high. This is just 2 values. So you literally just write -1 and 1. Those are the only answers you'll ever get in this problem. Okay, question on that? All right. So we can combine functions by adding, subtracting, multiplying, dividing. Dividing is really the only one that you got to really be careful what you're doing because of the dividing by 0. Another way we can create a new function from 2 that we already have is called composition. And the idea with composition is you're taking a function and plugging it into another function. And I'll show you how that works. So let's take these 2 functions. G of x is the square root of x, and f of x is x squared plus 3. Okay, the first thing is the notation. How do you write down a composition? And it looks like that. G of f of x. Now, if I wrote g of 9, how would you do that? If I said evaluate g of 9, what would you do? Yep.
You plug 9 into x.
You plug 9 in for the x in which function?
G.
G. You take the 9 and you fill it in for the letter in the g function. Well, this means the same thing. But instead of filling a 9 into the g function, you're going to fill in that, or whatever they give you. So you're going to fill in a formula for the variable rather than just a number. That's what composition is. Plugging in an entire formula for the variable. So let's try this one. G of f of x. First thing I like to do is just write down, okay, well, what is f of x? Okay. They tell me right here, f of x is x squared plus 3. So really, what I'm doing when I do the composition of those 2 functions is I'm taking x squared plus 3, which is f of x, and I'm going to fill all of that into function g. Where in function g? Everywhere there's a letter. So how would that look if I take all the variables in G and replace them with that? What would it look like? Yeah.
Square root of x squared plus 3.
Yeah, exactly. And that's the composition of those two functions. So that's g of f of x. We can also do it the other way, and instead of doing g of f, we can do f of g. It's usually not the same answer. Yeah.
I want to ask, for that last problem, could you simplify it to x square root of 3?
No, when you have a summation or a difference under a root, you can't apply the root to each term separately. You can apply roots to products. Like if you had x squared times 9, you definitely could do something like this and say x times 3 and break it up. But when that's a plus sign or a minus sign, no. All right, so now let's do it the bottom way. F of g of x. So first thing I do is start with identifying what that is. Okay. What's, Lizzie, what's g of x? Anyone help her out? How about Ryan? Can you help her out? What's g of x?
Square root of x.
Yep, square root of x. So that's the first thing we do, is change g of x to what it says it is. Okay, so now we got that. Now you're going to fill this in to function f. All right. So what would that look like? I don't want you to simplify, but can somebody just tell me if you change all the variables in f to that, what does it look like? Yep.
Square root of x squared.
Square root of x squared plus 3. Perfect. Now that does simplify. The square and the square root cancel, and you get x plus 3. So doing g of f and f of g doesn't give you the same answer. That's what I'm trying to show you. I don't use this notation. I'm just showing it to you in case you see it in the book. Sometimes you see like the G and then you see the F and they put a little circle between them. This symbol also means composition, but I'm always going to use this notation. I think that notation, I don't know, to me it's just clearer. Okay, so that second notation is the one you would always see on the test. All right, so how do you find the domain of a composition function? Well, there's two steps. When we do composition, there's always two functions involved. Okay. One of them I call the inside function. The other one I call the outside function. The inside function is the one that's in the parentheses. The outside function is the one that's in front. So in this case, G is inside, F is outside. When we're trying to find the domain of a composition function, first you start with the inside function. Okay, that's your starting point. And you're going to eliminate any values that are not allowed in that function. Okay, so we're going to rule out anything that you can't use on the inside function. That's step one. Okay, step two is we are then going to look at the final answer that we got. And when we look at that final answer, we're going to look at it for two things. Did the final answer have a square root in it? Did the final answer have a fraction with a variable in the bottom? If we end up with either one of those things, we need to make sure that we're never taking the square root of a negative and that we're not dividing by 0. So if there are any values in the final composed function that would cause you to divide by 0 or take the square root of a negative, you also need to exclude those values. And that's pretty much the 2 steps to finding a domain of a composition function. Eliminate any values that you're not allowed to use on the inside function. Again, looking for square roots and negatives and dividing by 0. And then eliminate any values in the final answer. Sometimes the final answer is fine, and there's no other additional values you need to exclude. Sometimes there is. All right, let's try. Well, I guess we can try this. So this is just evaluating with a number. It's not really finding domain and range in this one. And the way you do it is you start with the inside function and you work your way out. So the first thing they're telling you to do here is plug 9 into formula G. What do you get if you plug in a 9 in function G? Yeah, Jack?
3.
We get 3. Yep. So G of 9 is the square root of 9, which is 3. Now, what's f of 3? What if you plug 3 into function f? What do you got?
We get 12.
Wait, how'd you get that?
Oh, so well, the previous function of that. You get 4.
Yeah, you get 4. So 3 plus 1 gives you 4. So not really finding domain there, just practicing evaluating a number in a composed function. Now let's try to put it together. All right, f of g of x. Aiden, which function do we always start with, the inner or the outer? Oh, I'm sorry, not Aiden, Michael.
The inner.
Yeah, start with the inner. And can you tell me in this one, what is the inner function? I mean, I know its name is g of x, but what is it?
The square root of x.
Square root of x. Okay, so that's your first step. Now, take square root of x and fill it into function f. Kaylee, if I fill in square root of x into f, what would that look like?
Square root of x plus x plus 1.
Square root of x plus 1. Yep. Okay, not finding the domain of it right now, just still practicing doing f of g and g of f. Okay, let's try g of f. Okay, start with the inner function. Brian, what's f of x?
X plus 1.
So that's x plus 1. And now in function g, I want to take the x plus 1 and plug that in everywhere I see a variable. Right. So Lucas, if I did that, what would be my answer?
I was busy writing.
Oh, you're writing? How about Cecilia, can you help me out? What would that look like if you plug in x plus 1 for the variable in function g?
The square root of x plus 1.
So the same thing we had up here?
No, the square root would be over x in plus 1.
Yeah, it would be over the whole thing. So very important difference. Yeah. One of these is a vertical shift, the other one is a horizontal shift. So if you think of it in terms of transformations, they're very different. Okay. Any question on that one? All right, so let's Let's try one where we do the domain now. Okay, so first step, I'm just going to I'll write down what the function is, because you guys just did that. Then the new thing will be, you tell me the domain. So it's g of x squared minus 1. Now plug x squared minus 1 into formula g. Okay, so we have the composed function. Now I want to know its domain. Okay, now step 1. Eliminate any values that don't appear in the inside function. Inside function is f of x. Does f of x have a square root in it? The original example. What do you think, Bella? No? Ben, does it have a fraction with a variable in the bottom? No. So then, what do you think the domain is for f of x? If it doesn't have the two things in it that can give us a problem, the domain would be what? Yeah?
All real numbers.
Yes, the domain from part 1 is all real numbers. So in other words, there's nothing we need to eliminate from step 1. So right now we're at all real numbers. Okay, look at the final answer. Okay. Does the final answer have a fraction with a variable in the bottom? Okay.
No.
No? Does it have a square root in it?
Yes.
Yeah. And so we do need to be careful then. What do we want to make sure that x squared minus 1 always comes out to?
Positive number.
Positive or 0. So we need x squared minus 1 to always come out 0 or higher. So what that really means is we need x squared to always come out 1 or higher. Well, what kind of numbers can you square? And they will always come out 1 or higher. Yeah?
1?
That's the only number in the domain? Just 1?
No, or greater.
1 or greater. Yep, that's part of it. You can square any number 1 or greater. What other kind of numbers can you square and they will still come out 1 or greater? Yeah?
Negative numbers?
Can you be more specific? Because there's some negative numbers you can square that will not come out 1 or greater.
Negative 1 and less?
Negative 1 and less. Yep. So negative infinity. I just messed up my parenthesis on that. If you square anything lower than negative 1, well, negative 1 or lower, or 1 or higher, it will come out greater than or equal to 1. So that is your domain. So basically, don't pick a number between negative 1 and 1. That's what you can't use. Like 0.5, 0.6, negative 2/3. You can't use those numbers. All right, now let's try it the other way. Let's do f of g of x. Okay, g of x is, where is it? Oh, square root of x. So now I'm going to plug in square root of x into function f. So that's going to give me square root of x squared minus 1. Okay, what does that simplify to? Yeah? That simplifies to x minus 1. And you might think, oh, well, you can take any number you want and subtract 1 from it. Don't forget the first step. Eliminate any values that are not in the inside function. Okay. Does the inside function have a square root? Yeah.
Yes.
Yes, it does. So we need to eliminate all the values right away that would not work in this inside function. What numbers, Lucas, would you have to pick for x here?
0 or greater.
Okay, so now we're already limited to 0 or greater. Let's look at the final answer. Does the final answer have a square root in it? No. Does the final answer have a fraction with a variable in the bottom? No. So then step 2 doesn't add anything in this problem. There's nothing additional to do. So the only restriction came from step 1. And Lucas said that that was 0 or higher. So that's where, like, if somebody just came in and looked at that and said, what's the domain of x minus 1? They might say all real numbers. But you have to look back at where that came from. And it had a square root, but it canceled out when you squared it. Just the fact that it canceled out doesn't mean you can forget about it, because it was there. That's why we have to account for it. Any question on that? Range. So I'm going to just kind of simplify that, because when we do the range, we're really just going to graph it, and we're going to use that to see how high and low it goes. But we need to know where to look in the window. So the first step is find the domain. And then the second step, we're going to graph it and look at how high and low it goes. I'm not going to do g of f and f of g in this one. Let's just do f of g. Okay, so how about Cami, my first step is start with which function, f or g? Yep, I'm going to start with g, and we're going to replace g with the actual function, not the name. And Cami, what is g of x in this problem? X minus 3. Now, in function f, I want to replace all the variables with x minus 3. So Moises, if I did that, what would that look like? Perfect. Okay, so we've got our composed function. Now I want the domain. Start with the inside function. Maddie, what was the inside function again?
X minus 3.
Okay, does that have any square roots in it? Does it have any fractions with letters in the bottom? No. So then that means the domain was what? All real numbers. There's no restriction on the domain of g of x. Now look at the final answer. Does the final answer have a square root in it? Yes. So we are going to get a restriction we need to pay attention to from this. What values do you need to pick to make sure that x minus 3 always comes out 0 or higher? Yep.
Anything greater than or equal to 3.
Okay, so anything greater than or equal to 3. All right, so that gives me an idea of what I'm going to set my x min and max to. So I'm going to do square root of x minus 3. I'm typing in the composed function. Second, square root x minus 3. Go to window. I'm going to set my domain to go 3. I mean, it can go up as high as infinity, so I'm just going to leave it at 10 for now and see how that works. And I'll leave the y min and max where it is, and I'll just hit graph. All right, that gives me a pretty good idea of what it's going to look like. If you set the x max higher and the y max higher, you're just going to see it curve even more. But that's what a typical square root always looks like. It just does that. Never levels off. It still just keeps going up. So looking at that picture, what does it look like the lowest that graph ever goes is?
0.
Yep, the lowest it goes is 0, and it will reach 0 when x is at 3. Try it. Plug in 3 for x, you'll get 0. So 0 is the lowest. What's the highest that that blue curve is going to go? Yeah?
That would be infinite.
Infinity. It's just going to keep going. So your range is 0 to infinity. Okay. Any questions on that? All right, let's see if we can do this one. This one is a little different. In this one, I'm actually giving you the answer to the composed function. I want you to figure out how I got the composed function. So to compose a function, there's two originals, and then there's the composition. I'm not giving you one of the originals. I want you to figure out what that one would be. So the first one is essentially a vertical stretch. Somehow you're composing two functions together and you're ending up with a number in front of x squared. That's a vertical stretch. We talked about that yesterday. So look at what they're giving you. G of f of x equals ax squared. What do they tell you f of x is? Yeah?
X squared.
They tell you it's x squared. So what you need to do is figure out what could you put in this box so that if you filled this in for the letter, you would end up with ax squared. You've got to put something in this box that has an x in it, and when you take that and fill it in for the x, you end up with ax squared. Yep?
Could just be ax.
Yep, exactly. That's what it is. It's ax. Because now, if you take this and fill it in for the letter in function g, you'd replace the letter with x squared, and you get ax squared. Yep. So it's a times x. So it's a little different. Yeah, you kind of have to work backwards to figure out what the original function was. I think I got one more of those. Let's try this one. All right, so again, f of x is still the same thing it was up above. Now I'm looking for you to figure out what g of x is. What could you put inside that box so that if you replace the letter x in this box with x squared, you end up with x squared plus k? Yep.
X plus k.
Yep. So now if you took that and filled it in for the letter in function g, you'd replace x with x squared, and you get exactly what they wanted you to get. Yep. Okay, so we don't spend a ton of time on that. I'd say knowing the domain and range is more important, but that's kind of good to understand how that works at least. Sorry about that. All right, so the transformations. So I've told you yesterday, we're going to study transformations many, many times. We're going to study them with every single function that we look at all year. So we did them specifically with quadratics, but the transformations I taught you yesterday, they apply to any function. So what I want to do is look at, I'm going to show you a formula. And I want to see, based on what you know about the quadratic transformations, if you can tell me what the formula is doing. Okay. Actually, no, I'm going to do it this way, the way I said I was going to do it. Putting a number in front of a function. So yesterday we did things like 3x squared. This was always a quadratic yesterday. But if you put a number in front of a function and multiply, does anybody remember what kind of transformation that is? Multiplying by a number in front. Yep.
Or
Stretch or
compression.
compression, just depends on if it's bigger than 1 or less than 1. Yep. So vertical stretch or compression. How about adding or subtracting a number on the end of the function? That would be like x squared plus 2 if you were doing a quadratic. Yep.
Vertical shift.
That's a vertical shift, up or down. How about adding, but inside the function? What does that do? Yep.
Shift to the left.
That's a shift to the left. How about subtracting inside the function? Yep.
Shift to the right.
That's a shift to the right. We talked about negatives. If you put a negative in front of the whole function, that's the one where it made a difference on the parabola. We could see the difference. Does anybody remember which way that reflected it? Yeah?
Over the x-axis.
Yep. That's a reflection over the x-axis. Now, this one we did, we couldn't really tell because the parabola is symmetrical. A lot of graphs are not symmetrical. But if you put a negative on the inside, what does that do to it? Yep.
Reflect over y-axis.
That's a reflection over the y-axis. Okay, so that chart will be very helpful because it kind of generalizes transformations, not just to quadratics, but to any function, plus or minus a number. Any function with a negative in front. I think this is, yeah, we're not doing that one, and then that's the homework, so. This is, yeah, last page. Okay, does everybody have those? So let me show you the kind of question you could see. I'm not going to give you a formula in this one. I'm just going to give you an image. That's the image I'm going to give you. That's my f of x. What I want to do is take that picture and do this to it. If I want to take that image and perform all those transformations on it, can anybody tell me which number would I focus on first? This has to do with the order of the transformations we talked about yesterday. Yep.
Would you focus on the 2 first?
No, you wouldn't focus on the 2 first. There's a transformation that comes before that one. Yeah? The plus 1. What does a plus 1? And in fact, what I'll do is let me color code it so this makes sense. What does a plus 1 on the inside of the function do? Yep.
So shift to the left one.
Shift left 1. So that's the first step. I'm going to take that image and shift it left 1. So I'm just going to put that dot there, that dot there, that dot there. Okay, so there's step 1. Okay, what's the next number I would focus on? Yep,
2.
the 2. And what is the 2 going to do to all those points?
Shrink it.
No, it's not going to do a shrink. We are going to focus on the 2, but it doesn't shrink anything. Yeah?
Stretch by a factor of 2.
In which way does it stretch it?
Upwards.
Upward, vertically. Yep. So when you stretch something vertically by a factor of 2, it means to double all your y values. Well, where would this point end up if I double the y value? Same spot. Where would this point end up if I double the y value?
Same spot.
Same spot. And how about that coordinate at the top? where would that one end up? Yep.
Up
It would end up, it's already up 2 and we're doubling it, so it's going to end up here. So that is a vertical stretch. A ruler would help, but that's the idea. That's a vertical stretch by a factor of 2. And what is this minus 3 going to do? It's a minus 3 on the end of the function. Yep,
A vertical shift
down 3. So take every point, 1, 2, 3. 1, 2, 3. 1, 2, 1, 2, 3. So the final answer to this problem is the picture in blue. Any question on that? So that's the end of chapter 1. So talking about combining the functions to create new functions. Okay, so this will be the last Friday that is like this for probably a while, because next week we'll have our test, and there will not be any homework on the day we have the test. Okay, let me just double check that real quick. Just want to check 63. So that's the homework on page 66. Remember, that's not due until we come back on Monday for academics, so that would be on the 20. Oh no, 16th. Okay, so 16th. Test that week will start on the 19th. We have half a class on the 20th, so you have a little bit of time to finish up the test if you don't finish on the Thursday. Okay. I also plan on being here for extra help on the 12th next week. If anybody needs to come by and touch base with me.